working with solving quadratic equations 1.5. Now, a quadratic equation can be solved by completing the square, and that is solving for x after you've completed the square, or if it's already in vertex form, you can solve for x because it has already been complete. You already completed the square, and then next you're going to solve for x when y equals 0. Another way is to solve a quadratic equation is by factoring. When you factor the expression, you then solve for x. You solve for when the brackets equal 0. Last but not least, you can use the quadratic formula to solve a quadratic equation to find the zeros. To solve a quadratic equation means to be able to find the zeros, the solutions, the x-intercepts. Another way, which doesn't involve using any sort of algebra, is solved by graphing. This is the least most effective way because when the answer is a decimal, it is very hard to approximate exactly where the graph touches the x-axis. The number of solutions to a quadratic equation and the number of zeros of the related quadratic function can be determined using the discriminant. What is the discriminant? Well, first we need to look at the quadratic formula. So we're going to do a little song called the Quadratic to remember the quadratic formula. That is, x equals negative b plus or minus square root b squared minus 4ac all over 2a. One more time. X equals negative b plus or minus square root b squared minus 4ac all over 2a. X equals negative b plus or minus square root b squared minus 4ac all over 2a. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Now, this is the quadratic formula. You need to repeat this about 10 more times so that you'll never forget the formula. This formula is used quite often, in fact, more often than factoring, because there are many ways to be able to solve a quadratic equation using quadratic formula, whereas factoring really limits you. The discriminant is the part found underneath the root sign. That is, b squared minus 4ac is your discriminant. This helps you determine how many times the quadratic touches the x-axis. Here we go. B squared minus 4ac, when it is positive, that is greater than 0, what that means is that the parabola, the quadratic, will open either upwards and hit the x-axis twice, or open downwards and hits the x-axis twice as well. Either way, it's when the discriminant is positive that there will be 2 zeros, 2 solutions, 2 x-intercepts, 2 roots. That is 2 real roots, to be honest. The parabola will touch cross the x-axis twice, and that can only happen when the discriminant is greater than 0. What happens when b squared minus 4ac equals 0? Well, in that case, the parabola will actually touch the x-axis once. That point at which it touches the x-axis is the vertex. Whether it opens up or down, when the discriminant equals 0, there is only one real root, and that root turns out to be not just the root, but also the vertex. So there is one solution, one real root, And the parabola will only touch the x-axis once. So it doesn't really cross the x-axis as much as it touches the x-axis once. So what do we have left? We have positive, we have 0. That's right, we're missing negative. What happens when the discriminant is negative? Well, that means that the parabola will move away from the x-axis so that it doesn't touch the x-axis. Therefore, there are no solutions, no real roots. And in fact, the parabola never touches the x-axis, never crosses or touches the x-axis. So we have to remember that about the discriminant. It tells us how many times the parabola will touch the x-axis. This is going to be important in the future. Next, let's solve the following by factoring. So we're going to practice some factoring here. In the first one, this is a simple trinomial where the product is negative 12 and the sum is 1. What two numbers multiply to give you negative 12 and add to give you 1? That is positive 4 and negative 3. So our solution here is x equals negative 4 and x equals 3. In order, negative 4 and 3. In the next one, we need to find the product. The product is going to be a times c. 3 times negative 6 is negative 18. The sum is going to be the b value, which is negative 7. So the product is negative 18 and the sum is negative 7. So, to do that, we need to find the two numbers that multiply to give you negative 18 and add to give you negative 7, and that is negative 9 and positive 2. Negative 9x and positive 2x, when added together, will give us negative 7x. That's your outer and inner, your oi part of FOIL. To get negative 9x, I need to take from 3x squared a 3x, and I'm going to put the other x here. So a 3x and the other x right here. What that will help us is we've split up the 3x squared, which is the f part of FOIL, and now we can calculate what our outer number is. 3x times something gives us negative 9x. So we're going to take from the negative 6 a negative 3. 3 times negative 3 is negative 9. X times what gives you 2x? X times, let's hope you're thinking, that's right, plus 2. So what we have here is our FOIL. First will be 3x squared, no problem. My outer is negative 9x. My inner is plus 2x. That will give us negative 7x. And my last, 2 and negative 3, will give us negative 6. So that is how you factor this. Now, what are the solutions? Well, x will equal negative 2 over 3 and positive 3. Negative 2 over 3, because if you cover this up, the opposite of positive 2 is negative 2, and you divide by the number in front, which is 3. So it's negative 2 over 3. X minus 3, what's the opposite of minus 3? Positive 3 divided by 1, which is just 3. So x equals negative 2 over 3 and 3. Okay, moving on. Example 2. Solve using the quadratic formula. When you need to solve using the quadratic formula, it is important that you state the quadratic formula once somewhere along your test. The reason you want to state the quadratic formula is after you've stated it, you will not need to state it again and again. You can automatically plug in the values because it has already been stated at least once. So, in this example, we're going to do the quadratic formula so that we're ready to be able to use it. That is, x equals negative b plus or minus square root b squared minus 4ac all over 2a. That is, one more time, x equals negative b plus or minus square root b squared minus 4ac all over 2a. And the a, b, and c can be found when the quadratic is in standard form. So we state our a, b, and c. Our a is 6, our b is 7, and our c is negative 3. Now we plug into the quadratic formula. X equals, so negative b, so b is 7, negative b is negative 7, plus or minus square root b squared, so again 7 squared, minus 4 times a, which is 6, times c, which is negative 3, all over 2a. Once we plug this all in, what we can do, the next step that you must show me is you must show me the value of this discriminant. You must show me the value of this discriminant. That is negative 7 plus or minus root 121 all over 12. Once you've shown the discriminant, if it is a perfect root, you can find the square root of that, which will be, when I add negative 7 plus 11 over 12, which is 1/3. Then you also subtract x. Let's just move back for a second. Here we go. When we subtract, we take negative 7 and we minus 11 over 12, which will give us negative 3 over 2. So these are our roots that are exact. When I want an exact answer, I want no decimals. So they can be fractions or they can be reduced radicals. Let's look at the next example. 6x squared plus 14x plus 6 equals 0. What's important here is you need to common factor. Always look for a common factor, if at all possible, to simplify the quadratic. It makes using the quadratic formula easier, and in fact it makes factoring easier as well. In this case, we common factor the 2 and we get 3x squared plus 7x plus 3 equals 0. This is not factorable, so we need to use the quadratic formula. This in fact says use the quadratic formula. So our a value will be 3, b value will be 7, and c value will be 3. You might be asking, well, what happens if I didn't notice the quadratic form, that it was factorable, common factorable? That's okay, folks, because once you simplify the quadratic formula, the exact answer, you will actually get the same answer we get here. So we're going to use the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So we're going to plug this in. Negative 7, negative b plus or minus square root 7 squared minus 4 times 3 times 3 all over 2 times 3. Now the next step, once you've shown the plug and the substituted step, is you must show me the discriminant. X equals negative b plus or minus square root of 13. 49 minus 36 is 13 all over 6. So the two roots are going to be Now, some of you might be going, well, but I didn't get 13 because I forgot to common factor. Well, folks, you would have gotten root 52. Root 52 is reducible to 2 root 13. So somehow it would reduce itself to look like this, guaranteed, because there would be a 2 that's factorable from the top that can reduce with the bottom. Ultimately, when you add, you get negative 7 plus root 13 over 6 and negative 7 minus root 13 over 6. And here in blue is the example of what it would look like if you had not common factored. And you would get the exact same answer as we do in black. Now, what's important, folks, to note is that you should be able to know how to give me this in exact form. So exact answers only, which is exact roots. All right, moving on. Use the discriminant to determine the number of roots. So here we have 3 questions where you have to determine the number of roots. That is, we're going to use the discriminant. So if I ask you to determine the number of roots, you must use the discriminant. That is b squared minus 4ac. Identify a, b, and c for each case. And make sure that you use the discriminant. So the discriminant in this case is b squared, which is negative 4 all squared, minus 4 times 5 times 7. So it will be 16 minus 140, which is less than 0. We doesn't say we need to know the discriminant. In this case, all you have to do is use it to determine the number of roots. Sometimes you'll be asked to determine the discriminant, then determine the number of roots. If that's the case, you need to find the value of the discriminant. To determine the number of roots, you state whether the discriminant is greater than 0, less than 0, or equal to 0. In this case, our discriminant is less than 0, i.e. it's negative. Therefore, we say that there are no real roots for this particular equation. The reason there are no real roots is because this parabola opens up and it would be located above the x-axis. In this case, we identify the a, b, and c, and we find out that the discriminant equals 0 squared minus 4 times 3 times negative 3. Well, funny enough, the discriminant here is actually going to be positive because this will turn into plus 36. So 0 plus 36 means that it's positive, the discriminant. And if the discriminant is positive, that means there are 2 real roots for this function. The last one, a equals 1, b equals negative 4, c equals 4. Use the discriminant. Negative 4 squared minus 4 times 1 times 4. The discriminant will be 16 minus 16, which will be 0. So this time the discriminant actually equals 0, and therefore there is only 1 real root. Okay, moving on. Example 4. What values of k, where k is an integer, will allow each quadratic equation to be solved by factoring? What values of k? So, where k is an integer, that is, we need to know how to solve this equation by factoring. That is, in this case, and in this case, the k value is our sum. Our product in part A is 12, and our sum is k. K is an integer, so it could be positive or negative. So think of the factors of 12. What are they? Well, they're 1, 12, 2, 6, 3, 4. And we know that the sum of these values means that k could be 1 plus 12, which is 13, or we could do the negative of 1 plus 12, which is negative 13. 2, 6, the sum of those is 8. And if they were negative, both negative, it would be negative 8. 3, 4, the sum of those is positive 7. If they're both negative, it would be negative 7. And that's how you determine the values of k. So why don't you stop the video now and try the same for part B. Okay, we're back. Think of the factors of negative 15. What are they? The factors of negative 15 are negative 1 and 15, negative 3 and 5, and the opposite, positive 1 and negative 15, and positive 3 and negative 5. So k will equal negative 14 when I take positive 1 minus 15. And if I take negative 1 plus 15, I'll get plus positive 14. And then if I take positive 3 minus 5, that'll give me negative 2. And negative 3 plus 5 will give me positive 2. So plus or minus 14 and plus or minus 2. Those are the values of k. All right, moving on. Example 5. Find two consecutive whole numbers such that the sum of their squares is 265. That is, x. So consecutive means what? Well, 13 and 14 are consecutive. 13 and 15 are not consecutive. Consecutive whole numbers means you have to have 13 and the next number will be 14. That's what consecutive means. So if I have x as my first number, then x plus 1 is my next number. If I take the squares of both of these, that should equal 265. So we let x and x plus 1 be two consecutive numbers, whole numbers. So we solve for x by expanding. X squared plus, and we can expand x plus 1 all squared to x plus 1 times x plus 1, which will give us, when we FOIL it, x squared plus 2x plus 1. And then we move the 265 over, it becomes minus 265. And now we simplify. 2x squared plus 2x minus 264 equals 0. Now what we will do is common factor the 2 out of that entire expression, and then we're going to try and factor. You should look carefully because negative 132 is part of the 12 times table that you should already know. That is, negative 132 is the product and 1 is the sum, means that both numbers have to be very close to each other. That is, 12 times 11 gives us negative 132. So we have x plus 12 and x minus 11. That is, x equals negative 12 for this one and x equals 11. But only one of these values is correct because if we look back to the question, it says whole numbers. Whole numbers are countable numbers. A negative you cannot count on your fingers and toes. And any other item you can use to count. Negative is not countable. So, negative 12 is an integer. It is not a whole number. 11 is. So therefore, 11 is our number for x. What will be the consecutive number? That's right, folks. It will be 12. So therefore, the numbers are 11 and 12. And for those of you wondering what this is a double bar W. So you have a double bar like this, and you make a W with the first one. That represents whole numbers. All right, folks, that's the end of the video. Have a numerical day.